All right, we are going to begin 11.4, which is multiplying and dividing radical expressions. So I'm going to take a couple of the examples from your book first. Let's say we have the square root of 3 times the square root of 6. We're just treating this like that product property. So we're actually saying the square root of 3 times 6. We want to multiply the 3 and the 6, which would give us the square root of 18. Now I still need to simplify, so I'm going to go ahead and take those factors of 18, which would give me the square root of 9 and the square root of 2, and I'm going to separate it into factors again. By simplifying, this square root of 9 becomes 3. This would remain within the radical symbol, and that's our simplified version. Let's go ahead and try another one like that. Let's say I have the square root of 5 times the square root of 10. So I'm actually saying the square root of 5 times 10, which gives me the square root of 50. Factors of 50. With a perfect square, I have the square root of 25 times the square root of 2. The square root of 25 is 5, and then this will remains within the radical symbol, so that is our simplified version. Our next step is if we have something like this, where we have 5 times the square root of 3, and the whole thing is squared. So I'm basically saying 5 squared. Remember, this is using that distributive with the exponents. So I'm saying 5 squared, and then I'm saying the square root of 3 squared. 5 squared is 25. The square root of 3 squared, that radical symbol and the squared cancel each other out. So it becomes 25 times 3, which is 75. If we have another one like that, let's say I have 3 times the square root of 7, and I'm squaring this. So I'm saying 3 squared, and then I'm saying the square root of 7 squared. 3 squared is 9. The square root of 7 squared, cancels both of those terms out. So I'm saying 9 times 7, which gives me 63. And then the last step for this first section is if I have something like this, where I have a coefficient in front, I have something within a radical symbol, and then something else within a radical symbol. So I'm going to keep this 2 on the outside, and now I'm saying 8 times 4 times x times x. I multiply what's on the inside, take each of these terms. So now I'm saying 2 times the square root of 32x squared. I can go ahead and simplify this. I know I have 2 times x. X squared becomes x. And then I'm working with 32 within the radical symbol with just that number. 32, my factors, I have 2 and 16, 4 and 8. I'm going to go ahead and stop here though. I know 4 is a perfect square, but if I work with 16, then I have a bigger one and I'm not going to have to simplify it later. So 32 is 16 times 2. I still keep this 2x on the outside. Now when I simplify this, the square root of 16 is 4. So I'm saying 2x times 4 times the square root of 2. Now I still need to multiply these numbers out. I can't have 2 coefficients there. So then this becomes 8x times the square root of 2. That's our simplified version. Let's do one more like this. Let's say I have square root of 2m times the square root of 14m. That's going to give me the square root of 2 times 14 times m times m. So that gives me the square root of 28m squared. I know that the square root of m squared is m, so I'm going to go ahead and simplify that to m times the square root of 28. Now I can work with 28. My only factors here are 2 and 14 and 4 and 7, but 4 is a perfect square, so I'm going to have the square root of 4 times the square root of 7. This m still remains on the outside. My square root of 4 is 2, so I have 2m times square root of 7. And remember, I always want my coefficient, my number, my constant to go in front of the variable. And then whatever's in the radical symbol stays at the end. I don't ever want to put a radical symbol at the front, otherwise it looks like I'm saying the square root of 7 to m. That's a little too messy, and you run the risk of making sure that we don't know that this radical symbol goes at the end. Okay, now let's say I have something like this. This is just using the distributive property. If I have a radical symbol on the outside, I'm multiplying it by this. Now this 5 is still a constant, so I have to say 5 times the square root of 2. The square root, the radical needs to go after that constant. And then when I multiply 2 within the radical symbol, I'm multiplying those two numbers and keeping them in a radical symbol. So I'm saying 2 times 12. 5 times the square root of 2, I cannot simplify that because 2 is a prime number, so it's going to stay like that. I'm going to use 24, and let's see, I have 2 and 12. I have 3 and 8. I have 4 and 6. 4 is my only perfect square, so this is becoming the square root of 4 times the square root of 6. I still have the 5 times the square root of 2. This square root of 4 can become a 2, and I bring that down, and then this remains the same. This is as simple as it can get. I can leave it as two separate terms. That's okay. So let's go ahead and try another one along those lines. Let's say I have the square root of 6, and I'm multiplying it by the square root of 8 minus 3. With this distributive, I'm going to say square root of 6 times that. I'm going to get the square root of 48 because I am multiplying the 6 and the 8. So square root of 48. And then I'm saying times this is minus. I'm going to keep that 3 in the front times the square root of 6. Again, I cannot simplify the square root of 6, but I know that 48, I have 2 and 24, I have 3 and 16, I have 4 and 8, I have, 4 and 12, and 6 and 8. So I have 4 as a perfect square and 16, so I'm going to always use the bigger square root. So I have the square root of 16 times the square root of 3 minus 3 times the square root of 6. Let's go ahead and simplify what we can. The square root of 16 is 4. 4 times the square root of 3 minus 3 times the square root of 6. That is as simplified as it can get. Now let's say I have two what looks like binomials with radical symbols. So I'm going to use that FOIL. So I have first, it's going to give me 12. Outers is going to give me, I have a negative square root of 5 here. So I have a negative 4 times the square root of 5 when I multiply those. Inners is going to give me a plus 3 times the square root of 5. And then last is going to give me a minus square root of 25. Now let's go ahead and simplify what we can. This 12 is going to remain the same. These two are like terms, so I keep that radical symbol the same, but I work with the coefficients. So I have a negative 4 and a positive 3, which is going to give me a negative 1 times the square root of 5, or just a negative square root of 5. And then minus, and the square root of 25 is 5. Now I can still simplify. I have 12, and I have a negative 5, so when I simplify these, I'm going to get 7. This remains, so it's 7 minus the square root of 5. I'm going to go ahead and clean that up. 7 minus the square root of 5. And that's our simplified version. Let's do one more with FOIL. Let's say I have 4 minus the square root of 3 times the square root of 3 plus 5. And again, I'm going to go ahead and do this first. That's going to give me 4 times the square root of 3. Outers is going to give me plus 20. Inners is going to give me a negative square root of 9 because I multiply what's in the radical symbol. And then last is going to give me a negative 5 times the square root of 3. Go ahead and combine like terms. I know I have 20 at the front. And then I have 4 times the square root of 3 minus 5 times the square root of 3, which again is going to give me a negative 1, which I don't need the 1 as a coefficient. So I'm just going to say negative square root of 3. And then minus the square root of 9. The square root of 9 is 3. So again, now I can combine my constants. So I get 17 minus the square root of 3. And there's my simplified version. So far, everything we've done has been with multiplication. So we're going to work with division. Our first step is going to be to look at this and say, is there anything that I can throw inside the radical symbol together to simplify? Now, 7 and 2 are both prime numbers, so I know I cannot simplify them. So I'm going to keep it like this, but my only thing is I cannot have a radical symbol on the bottom of a fraction. So I have to multiply this by whatever's on the bottom, which happens to be, in this case, it's a square root of 2. So I have to multiply the top by a square root of 2 and the bottom by a square root of 2, because now I'm actually multiplying it by 1, but that's going to help me eliminate this radical symbol. So when I do that, I get the square root of 14 on top, and then I get the square root of 4. Now I can simplify that to 2, so I get the square root of 14 over 2. That's going to be my simplified version when I'm working with a rational as the denominator. Let's go ahead and do another one like that. Your book gives this example, square root of 7 over the square root of 8n. Again, I can do this. I'm going to go ahead and do it a different way than your book says. It says to simplify the base first, but I'm going to go ahead and do it this way, where I multiply by the square root of 8n, multiply by the square root of 8n, So I multiply top and bottom by the same thing, so I'm essentially multiplying by 1. Now I get the square root of 56n. I want to make sure that that's all in a radical, over the square root of 64n squared. Now I could simplify the 64n squared to just 8n, and then I have the square root of 56n on top. Now, the 56, I'm going to go ahead and look at, are there any numbers in there that I can simplify? So I have 227. Doesn't look like 3 goes into there. 4 goes in 14 times. 5, 6, and then I can do 7 and 8. So let's go ahead and say that I have this 4 and 14, because that's our only perfect square. So I'm going to say the square root of 4 times the square root of 14n, because there's only one variable there. There's no exponents, so I cannot simplify that. The square root of 4 is 2, so I'm going to have 2 times the square root of 14n over 8n. Now, if you notice, this 2 and the 8 can simplify to 1 and 4. So now I'm going to get the square root of 14n over 4n. I know that was a long process, but that's going to be our best way of doing this. Okay, let's try one more like that where it's going to take a couple of extra steps. Let's say I have the square root of 5a over the square root of 12. I'm going to multiply both of these by the square root of 12 over the square root of 12. So I'm multiplying by something that gives me 1. So now I have the square root of 60a on top, and the square root of 144 on bottom, and the square root of 60a over 12. Now let's go ahead and look at the factors of 60. I have 2 and 30. I have 4 and 15. I have 5 and 12. I have 6 and 10. That looks like it. 4 is my only one here that is a perfect square. So I'm going to go ahead and say the square root of 4 times the square root of 15a all over 12. Now again, this 4 can simplify to 2, so I'm going to get 2 times the square root of 15a over 12. And look at it again, I can simplify this 2 and the 12. That becomes a 1, that becomes a 6. So I'm saying the square root of 15a over 6. I just want to double check that at the end I do not have a radical symbol on the bottom as a denominator. And once I've done that and made sure, then we're good. All right, this is probably one of the hardest lessons that you've seen so far in the last few weeks, and that's okay. It's going to take a little bit more time, but I believe in you. Because this is a little bit more, we're only going to have 2 assignments this week. So for 11.4, you're going to do page 719, numbers 2 through 54 even. Good luck. Let me know if you need any help.